theta equal to 0 to 2 pi, if we substitute here, then this kind of curve will be obtained. So first let me find out what is the area here. Area is this curve here from 0 to 2 pi, limits. So let me find out this limits. Therefore area here, area of the required curve, or area of the required curve. Find the area included between the curve, this and this. Let me just put here, sorry. Let me put here the required area. The required area of the curve here. Okay, so from 0 to pi by 2 pi minus, or we can take different value, pi by 4 as well. 0, pi by 4, pi by 2, then pi, then 3 pi by 2, then 2 pi finally. 3 pi by 2 and 2 pi. So what are the different values of theta? If we calculate, let me calculate some values. Theta here, we will substitute 0, pi by 4, then pi by 2, then pi, or let me take 3 pi by 4, it is 3 pi by 4 here, 3 pi by 4, then pi to pi by 3, 2 pi by 3, then 4 pi by, 5 pi by 2 pi by 3, 5 pi by 4, 7 pi by, 3 pi by, this is 2 pi by 3, then 4 pi by 3, and 2 pi final. So in this way, up to 2 pi, 0 to 2 pi, different values if we calculate, this kind of curve will be obtained. So this is 0 to pi, we have to substitute, and x we calculate, y we calculate, dy dx we calculate, what are those values. At pi by 4, naturally this is pi by 4, that means pi by 8 it will be. If I put, and pi by 2, then it is pi by 4, it is 1 here. At this, but at pi by 2, it is pi by 4, so cot pi by 4 is 1. Sorry, this 1 is here, and dy dx. So different values. At 0, theta is 0 here, 0, it is 0, 0 minus 0, this is 0x. Y is, this is 0 is 1, 1 minus 1, 0, y is also 0. Now dy dx is here 0, if I substitute, this is cos 0 upon sin 0, is infinity. Because cot, if we are putting here 0, so cos 0 upon sin 0, cos 0 is 1 here, but sin 0 is 0, so 1 upon 0 is infinity. In this way, all the values can be calculated. So this kind of curve will be obtained. So area finally we have to calculate. So area is from 0 to pi, 2 pi limits we have taken. So y into dx upon d theta, that we take. So limit will remain the same. So here area is twice, not twice here, but only this total area is there. So it is 0 to 2 pi, y into dx, that is equal to 0 to 2 pi. It is y is here, that value we will substitute, and dx, let me first write dx dt, dx d theta into d theta. Because theta, no, these limits are 0 to 2 pi, finally limits. Y is here, this is 0 to 2 pi limits, a into 1 minus cos theta, limits are, and this is y value, dx d theta is here, 1 minus cos theta, a into 1 minus cos theta, because after differentiation, dx d theta will be a into theta is 1, cos theta is, sorry, sin theta is cos theta, so a into 1 minus cos theta we have substituted here into d theta. Now this is equal to a square here, let me take outside, 0 to 2 pi, this is nothing but 1 minus cos theta whole square. Okay, so if I into d theta, and 1 minus cos theta, we know that. What is that? Let me now write here. So we know that what is 1 minus cos theta. This is a 0 to 2 pi. 1 minus cos theta is 2 sine square theta by 2. 1.2 theta is whole square into d theta. If I put theta by 2 equal to, let me take theta by 2, or put 1 theta equal to phi, let me take. Okay, so just we put the limits here. Then phi at limits can be changed. D phi equal to d theta or twice d phi. So theta equal to twice phi. Theta equal to twice phi. D theta equal to 2 into d phi. Limits are now, if I convert them, and what are the limits then? At theta equal to 2 pi, phi is, okay, let me take. At theta is equal to 2 pi, phi is equal to pi. At 0 it is 0. At theta 0 it is 0. At theta equal to 0, phi is 0. Okay, so finally this will be 2 theta here, 2 d phi. So this is twice a 0 to pi. Okay, this is 4 into sine 4. This is phi here into d phi. Okay, now we know that if I convert this into, okay, so this is the final value here, cos 4 phi. Okay, now this is 4, 8 is 8 into a, it was a square, I think, a here. Okay, this is, I'm sorry, here we substituted the value of, I think this is a square, because a square came from here. So dx d theta into y was also a. Okay, it is a square, I'm sorry. Because dx d theta is also in terms of a into 1 minus cos theta. And here y was this, y equal to this, and dx d theta is a into this. Okay, so this is twice a square, I'm sorry, a square here. So this is 8a square. Now this 4 into 2 square, 4 8a square. Okay, into 0 to pi. Now if I convert this into limits 0 to pi by 2, then twice it will be there. So 2 into pi by 2. Limits, this is definite integral formula. We can convert them into this. So this is sine 4 phi into d phi. So finally, by reduction formula for sine, for cos of sine, we know that, what is that? This is 16a square. 2 into 8, 16a square. And this is 3 by 4, 3 by 4, then 1 by 2, I'm sorry. This is 1 by 2 into pi by 2. Okay. This is 4 to the 8 to the 16, so 16 cancel out. This is nothing but pi, 3 pi a square. 3 pi a square. Is it answer given? No. Only 3 pi a square is the answer finally. So what we did, we just traced the curve like this. The curve here, 0 to theta equal 0 to 2 pi, limits we substituted. But there are different values. If we find out, then y, what is y here? Y maybe in terms of 2a. Y is find out as 1 plus 1, 2. So it is twice a here. Here it is a, I think y. Here it is a again. A. And up to this is twice a. This is just like that. Okay, so twice a, here it is a at different angles here, and this is 2a pi. Okay, a pi something, and x is coming here on the x-axis. So this distance, I think a pi is here. This is 2a pi up to this, and this is again a pi and this value. So this is how x values are calculated. So different values of x, y, and dy dx, if we calculate, this kind of curve will be obtained, and the area is 3 pi a square. Finally, answer is this. This is question number 4th we have done. Let me take the 5th question now. So question number 5th. Let us talk about it. So question number 5. What does it say? Question number 4 we have done, or question number 4 we did. Now let me take the 5th question. What does the question number 5 say? Okay, so question number 5. Question number 5 here, 5th question. Question number 5, what does it say? Show that the area bounded by the cissoid, bounded by the cissoid, this x equal to this equal is 3 by 4 pi a square. We first write, and its asymptote and cissoid. So between the cissoid and asymptote, area is this. We have to show. Question number to show that area under the cissoid and its asymptotes is, what is that, 3 by 4 pi a square. This is the area. Okay, so this we have to prove. What is the cissoid here? X equal to a sine square t, alright, and y is equal to a sine qt upon cos t. Okay, now if I square this y square, this is second equation, this is the first one. Let me eliminate the t parameter. So applying parameter elimination method. Solution. Applying elimination method, parameter elimination method. It's known as elimination method simply. Parameter elimination method. Okay, we'll get Cartesian form of the equation. After that, we will test it, and we will see that what kind of figure comes out, and after that we will calculate the area. Okay, that is the process. Now let me solve it. So squaring the second equation, we get, what do we get here? This is y square equal to a square sine 6t upon cos square t. Now we can write it as a square outside, no problem. Sine square, this can be written as sine square t whole cube upon cos square t can be written as 1 minus sine square t. Cos square t is 1 minus sine square t, and this is 6 power, so 2 3 is 6 sine square t whole power. Now sine square t is from first. Putting, since sine square t is equal to x upon a from first, substituting this value in this third one. So we get, what do we get here? This is y square is equal to a square into sine square t is x upon a. So this is x upon a whole cube divided by 1 minus x upon a. This is x upon a. So we obtain, this is a square x cube upon a cube divided by whole a minus x upon a. 1 a cancel out. This is a square. Okay, so a square into a minus x, or a square is also cancelled out by this a square. Okay, so what do we get here? So the Cartesian form of the equation obtained is, let me write here. So finally, y square into a minus x is equal to x cube. Okay, this is x cube on the right. Now, this is the equation which we have obtained from elimination method. Eliminating the parameter, and we have obtained this curve. So this can be written as y square equal to x cube upon a minus x. What do we see here? What is this kind of curve? If I put x equal to a, y square equal to infinity, plus minus infinity. Okay, so this curve is in, okay, y square. So the curve obtained will be symmetric to x-axis here because y is even forward. Let me now describe the curve and then trace the curve, and finally we will solve for area. So this area, this curve is symmetric about x-axis. Is symmetric about, this is seesaw form, symmetric about x-axis as y is even forward. As y is even forward. Okay, there is no constant term, so it will pass through the origin. Constant independent term is not there. It will pass through the origin. It will pass through the origin. It will pass through the origin. Through the origin. As there is no independent term, constant independent term. No independent constant term, constant independent term, sorry. So constant independent term is not there, so it will pass to the origin. And at x equal to, third one, at x equal to a, y square tends to infinity, or y tends to plus minus infinity. Okay. And beyond x, if I put x equal to 2a, 3, etc., this y will be negative. So fourth point, at x greater than a, y square is negative. Y square is negative. So curve does not exist beyond x equal to a. Beyond x equal to a. For x greater than a, curve is negative. So beyond x equal to a, the curve does not exist. What kind of curve is this? Let me draw that. Or sorry, beyond x equal to a, undoubtedly. And for x negative values also. Because if I take beyond the 0 for positive value of x, the curve is not existing. So let me, or for negative values also. If I take x negative here, so this is okay, positive, but this will be negative. For that also y is negative. So beyond negative values, for x negative values also, the curve is not existing. So that means what kind of shape of the curve we will obtain. So this is this kind of curve. Okay, here the curve is having asymptotes. This is at x equal to a. This point is a0. At x equal to a, y tends to plus minus infinity. This is plus minus infinity. This is 0, 0 point. And this is O origin. The limits are from 0 to a. We will find out. And this is the elementary strip we have taken, PQ. This is dx here. Or PQ, let me take here. This is MN. Okay. These 2 points are MN. And the width of this is dx. This is M point, this is the end point of the strip, and dx is the width of this. The total area of this seesaw is this is known as seesaw. Okay. Now this is node shape because y square was plus minus. Okay. I mean here y square is that value. Okay, so it means it's a cuspodial type. This is not cusp, but it is a cusp type. Sorry, it is a cusp type of figure. First species of cusp we discussed about. This is a cusp here, but infinity at x equal to a, y tends to infinity plus minus infinity. So there is asymptote here. Between the asymptotes of this seesaw, we have to find out the area. So this total area is twice of this area. But let me write O, here it is A, and this is B, let me take. OAB twice of that area. Total area therefore is, let me write, this is y equal to this value, but we are not to find out this y, we have to find out y into dx, no problem, but y we have to replace by from this value in terms of this, and then dx dt, okay, and into dt, so that we have to calculate. So only for shape of the curve we have found out this value. Let me find out by here total area or required area of the curve is equal to twice area OAB. This is twice of limits 0 to, okay, x is from 0 to a, y into dx. Now it can be written as 2 into, because at x, if I put 0, sine is 0, no, t is 0, so 0, but at a, sine is pi by 2, so 0 to pi by 2 limits. Why? Because here x, these are the x limits, 0 to a, x 0 to a. If I put here x equal to 0, then sine square t equal to 0, because 0 upon a is 0, so t is 0. But at a upon a 1, sine square t is 1, sine t is 1, that means sine pi by 2, t is equal to pi by 2. 2 to pi by 2 here. Now y is this value. We can write here y dx dt into dt, no problem. Okay, then we calculate this value by putting y is 0 to pi by 2. Y here is this value, a into sine qt divided by cos t into dx dt. Dx dt is this twice, or let me write here dx dt. Find out here dx dt is twice a sine t into cos t. Alright, into cos t. This twice a sine t into cos t into dt. The dt. Dx dt is twice a sine t cos t. Cos t cancel out. Twice a 4a square is equal to 4a square, 2a into a, 4 into 2, 4a square, 0 to pi by 2. Sine t and sine qt is sine 4t into dt. Okay, so sine 4t. Now applying reduction formula. Finally, what is the answer? Let me write here. So finally, answer is by applying reduction formula for this 4a square sine 4t dt, 0 to pi by 2 limits, is nothing but 3 by 4, 1 by 2, pi by 2. 1 4 cancel out. This is pi 3 pi a square upon 4. What is the answer? 3 by 4 pi a square. All right. 3 by 4 pi a square here is the answer here. I mean, hence proved. So it has been proved here. Finally, answer is 3 pi by 4 a square. 3 by 4 into pi a square. Because this 4 cancelled out, a square 3 pi by 2 into 1 by 2, that will pi by 4. So 3 pi a square upon 4 is the answer. Finally, we have obtained 3 by 4 pi a square. This is the answer here. Okay, the final answer. Now question number 6, I'll take after 5 minutes because I'm in a hurry. Okay, so see you in the, okay, after 5 minutes, let me take some break. Okay, then see you.